Okay, pediatrician wants to determine the relationship between height and size of the head. And it seems reasonable to think that taller kids will have bigger heads. Just taller kids will have bigger body parts in general. So wants to use height to predict circumference. So this is number 4. It's always X predicts Y, because Y equals mx plus b. If we know the X, we stick it into the equation and we predict the Y. So it's always X predicts Y. So height to predict circumference. So height is the X. Height is the explanatory. Height is X predicts Y. Height predicts circumference. Height is the X. Height is the explanatory. Okay, continue. Draw a scatter diagram. Well, we can do this in StatCrunch. We open the data in StatCrunch, switch to my other mouse to pull the window over, right? And you see, as usual, StatCrunch has already pulled the data for us. So this is one case where we use graph, where because we want to plot a graph, we want a scatter plot, so we do graph scatter plot. X is the X, the height. Y is the circumference, compute. And here is the plot. So it looks like it kind of goes up and it levels off. So when we look at these, A looks possible. It goes up and levels off. B is wrong. C is wrong. D is possible also. And what's the difference between A and D? It's the label. A has height going across. D has circumference going across. Well, the X is height. So D is incorrect. The labels are switched. The correct answer is A. And I agree, Nadine. This does not look linear to me. It kind of looks linear up to a certain point. It's almost like if the kid is shorter, then the head may be somewhat smaller. But once the kid is kind of a regular to taller than usual, the heads are the same size. Okay, check answer. And let's continue. Compute the linear correlation coefficient. So now we're back into summary stats. Before we used columns to compute the mean, standard deviation, all of that stuff. Here we want correlation. Correlation, it doesn't matter which one you select first and which one you select second. Compute, and there's the correlation. To 3 decimal places, it's 730. So is this positive correlation or negative correlation? I'll show that, Nadine, again. Positive or negative correlation? Well, the correlation is positive, which suggests positive. And when we look at the scatter diagram or the scatter plot, yes, there's a bend, but there is a general trend going up. Okay, so the general trend going up, the positive correlation, they agree with each other. So how do we get this? This is under summary stats. Summary stats are where we find calculations for the mean, the standard deviation, and the correlation. Okay. Does a linear relationship exist? We already looked at it and said no. Oh, okay. Now this is kind of weird. Click here to see the critical values. So if we click there, how many data points do we have? Well, we have 8 data values. 8 data values, the critical value is 0.707. In other words, anything, this is the classical method for hypothesis tests. Anything higher than 0.707, anything lower than minus 0.707 is significant. So here we're higher. So yes, there is a positive association because R is positive and greater than the critical value. However, even though R is positive and greater than the critical value, doesn't mean that a linear regression model is the best one to use. It just says that it's possible. We have to be smarter and look at the plots and things like that to decide whether it's the best one or not.